Welcome back to Nature of Code in Rust and GGEZ. Today we're going to be going over example 1.11, array of movers accelerating towards the mouse. So this is going to be fairly simple and similar to our previous mover examples and exercises. We're just going to make it so we have a whole bunch of these balls all moving towards the mouse. Now, these are going to be fixed acceleration, unlike the last exercise in which we had the variable acceleration, although the same idea is present. So let's go ahead and do this in our code. So the first thing that I want to do is I want to rip out what we are doing with the we're going to go back to just normal acceleration here. So I'm not going to have a scale distance. I'm going to have my scale be 0.05 again. Maybe it's like 0.5. I can't remember. So we're not going to have to, we are going to multiply scalar, but it's going to be self.scale. Then we'll have our, direction, normalize. All of this should remain the same. So now if I run this, we should have a single ball always moving towards the mouse in a constant acceleration. This may be a little bit too slow. I think our initial idea was 0.5. Let's try this again. That feels a lot better. Okay, so now if I want multiple of these, I'm going to head into our main library. And we're going to see how we end up creating these. So we have a new mover and we tell it exactly where it needs to be. We're going to want to create a number of these. The book has us create 20 of them, and that's fine. We can create 20 of them pretty easily. We need to make sure that we create them with a random location all around the world. The arena. And I'm actually curious about this. Yeah, so they start in random locations every time we hit reset. So we can do that. We're going to create a random number generator here. It's going to be a thread RNG. And then we'll be able to create our random number generator. Let's go ahead and create a loop that's going to loop over 20 times. So and then I don't think I really care about like the count in this. So I'm just going to use underscore as just to throw away this value. And 0.20. Okay, so this is going to loop over 20 times. We're going to want to get that the point, essentially, the x and the y. So let's create that randomly first. So x is going to be equals to rand gen range. And this is going to be between 0 and the width. And y is going to be the same thing, between 0 and the height. Okay, that's going to give us a completely random location. So we can now create our mover inside of here, which instead of just putting it in the exact center, this is going to be our x and our y, and then we also handed the context. You are upset because you need in Spanish types found it an F32. Oh, you both need to be 0.0. All right, that makes that happy. We no longer have mover. Notice that we're creating it inside of the block, and because Rust is block scoped, this mover just goes out of scope here and then just gets dropped, removed from memory. However, we don't want this mover to be just a singular mover anymore. We want this to be a vector of movers. We could do an array as well. That would work out just fine. However, in this case, I want to do a vector just so that it's easier to like push these in. So do a vec, and then the type that's inside the vector is going to be a mover. Okay, so we create our mover here. Let's actually, above our for loop, we're going to we're going to now create an empty movers. Let's actually rename this to movers. So that mute movers is equal to, we're going to use the vec macro, and we're going to push this mover in. So movers push mover, and then store movers away. All right, so that should make that happy. Down here in update, we need to make sure we run this for every single mover in that vector. So the way we're going to do this is just a standard for loop. For mover in self.movers. Well, there's a problem here. We're taking ownership of mover, and that's a no-no in Rust, because the next time that we go around this, it's going to, we're not going to have ownership anymore. So we need to mutably borrow it. So we can do &mute to borrow this mutably, and now we have a mutable reference to the mover. We can then move these up into here and just get rid of self. So it's this specific mover that we're running these updates in. And we can do the exact same thing for this, this draw. In fact, we can just take this for loop, push it in here, and then we'll just do mover.display, pass in the context, and we can even use question marks inside of this for loop. So let's go ahead and run this and see how it works. And now we have a whole bunch of balls all chasing after the mouse. So this is a great way for, we're now able to easily have a vector or array or list or whatever terminology you want to use. Vector is the most appropriate here because that's what we're using. But whatever is able to allow you to sort of see what we're doing. That it's a list of these movers, and we're able to iterate over them to run their update methods and to also display them out. Now there's other ways for us to be able to do this. For example, I don't have to use for. If you're coming from JavaScript and you're used to array methods like for each, or maybe a map or reduce, well, for each would probably be the most appropriate here. Let's go ahead and try a for each. So we have a vector of movers. So we're going to do self.movers. Now I can't just call for each off of here directly, but I can get an iterator off of it. I do need to mute movers, so we need an iter mute. And then we can do a for each. A for each, now we're going to give an actual function to go in it. So I'm going to hand it a closure. Closures in Rust, the parameters, or the parameter list is by vertical bars. And so our mover comes in here, and Rust Analyzer is telling us that's going to be a mutable reference to a mover. And then we can just write whatever code we need here. It's exactly like fat arrow functions in JavaScript. We can just put the one-liner if we have it, or we can have curly brackets, use a block, and then write whatever we need to. So in this case, mover.walk, and the context, mover.update, and then mover.checkEdges with the context. And we're done. So if I run this, everything is exactly the same. We still have all of our movers chasing after the mouse. So it's highly dependent upon how you feel about it, because this is, this works just as well as the for loop. Now down here where we have this display, we notice we have this question mark. So if I wanted to be able to, if I wanted to do a for each with this one, it would have to be subtly different. We have to be able to handle that result that could potentially come back, the error result, essentially. So we're going to do self.movers. We're going to do not into editor, iter mute. Actually, we don't need iter mute. We can just use iterator because we just need a reference to it. We don't need a mutable reference to our mover. Then we need a try for each. Try for each is going to return a result. So it assumes we're returning a result inside of here. So we're going to get a mover. It's a reference to a mover that we see. And here we can just do a single line because there's only one thing that we need to do. So it's going to be mover.display. We pass in the context. This returns an error. And then we have to put a question mark on the outside of this try for each. And that's because try for each can return whatever error is returned from in here. So it's sort of like bubbling out. And this is it. This is how we can now have a for each loop, essentially a vector method in Rust. And that is example 1.11, the array of movers, or in this case, vector movers, accelerating towards the mouse. Thank you so much for watching, and I'll see you in the next video. Bye.